Okay, now that we've got our character all ready to go, weights painted, and he's deforming well, we're going to start getting into the heart of rigging. So with that, I've set up just this little scene here to talk about a few things with controls and and constraints and different connections that we'll be using. So basically, each of these is a very basic rudimentary rig. It's a polygon mesh that's bound to a joint, and the joint is controlled by a NURBS curve, so which is our puppet controls. So when we start using and doing rigging, we're basically creating this exoskeleton of controls that are a lot easier to pick than the joints. And there's a lot of different connections that we can make, but we want to keep our NURBS curves separate from the hierarchy of the joints that we have. So we do that by using constraints. These are your kind of constraint options and buttons up here. But just to kind of run through them really quickly and talk about them, you can find them underneath the rigging and animation tabs under constrain. And there's a parent, a point, orient, scale, aim, pull vector. These are all different types of constraints that you can have. So I've set up various ones. So you know this is the parent constraint. And the parent constraint is just going to treat the joint just like it's a child of that, like you had parented it to that object. So it's set up right now. So yeah, if you move the control parent would in a normal hierarchy. Now, the point constraint, it's going to act like the parent, but only on the translate values of translate X, Y, and Z. So you can see here, I can move it. It moves just like you would expect, but then when I rotate, it does not rotate at all. So it's just the translate. And that's this button right here. The next one is your orient constraint. And that is right here. So orient is going to do the opposite of your point. It's going to rotate and not translate. So I can rotate it like I normally would, and it's going to rotate. But if I move the control, I get nothing. No movement happening there. So that is the orient constraint. And then we have our scale constraint. And this one is just going to affect your scale, X, Y, and Z. So I move it around, nothing happens. I rotate it, nothing happens. It's only when I scale it will I be able to do that. So the last constraint is an aim constraint. So this is where the joint is always going to point at the control that you have selected. So in this case, if the movement of the controller object is going to determine the rotation of the object it's controlling. So I move it around, use this a lot with eyes. And there's other stuff that it's handy for. But so it's always just going to be looking at that control. So there's a pull vector constraint. We'll talk about that when we get more into IKs. But those are your basic constraints. So, and there's different times that you're going to want this different functionality where you're like, yeah, I want to be able to set up one control that will control the translation and a separate control that's going to control the orientation. So each of these constraints has options in under the controls and their option box. You can see them here. Maintain offset means it's going to leave the child wherever it is. Whatever control you're having can control the other object. The object that's being controlled is going to stay in place. If I uncheck this and I had a control over here and I was trying to control this object and I didn't keep maintain offset on, it would move that object to the pivot point of the controller and then it would bind it. And then you have these options to do all translate and all rotation, and then the weight of how much that is on from 0 to 1. So you can go in and say, hey, I want all my rotations, but I only want my translate Y. And you can certainly do that, or any other combo that you need there. So default is usually all translate and rotation for that. Then the other options, if it's the point constraint, it's only going to have translate options that you can turn on and off. If it's an orient constraint, it's just going to have the rotate options on or off, and same with the scale. So they're all pretty straightforward. The aim constraint is a little bit different, and it's important to be aware of your joint orientation or the object orientation so you know which way it's going to be aiming. So right now, turn the maintain offset on, so it's not going to change any of the rotation. And we have this aim and up vector and the world up vector, so which are both on Y. And then we have, and then for this, we want Z. So the aim vector, we would want Z. So we would set this to 1 and this to 0. And then up is still Y, and the world up vector is Y as well. And we would apply. And then you can do the same thing. You can set which axes you want, and you can set the weight of it. So all pretty standard options with constraints. But yeah, knowing which axes is pointing out will help you determine which aim vector you want to use. So, and that will give you all of this wonderful functionality. So, and all that's doing is it's aiming. It's just pointing right at that control at all times. All right, you can see I can rotate it sideways. It's not going to do anything. Rotate it this way, it won't do anything. It's just the position. So whenever you set up a constraint, you're going to select your control object, and then you'll shift select the object to be controlled, so the joint. When you make a connection, you'll notice that it has blue on here. So blue tells you that there is a constraint that is happening on these channels. Now I can go in and rotate and move it like I normally would without a constraint, and it may look like it is doing what you've told it to do, but as soon as you touch your other control and you move it, it's going to snap right back to it. So you can't key anything that has a constraint on it. You kind of can, but it's going to create this blend where you're going to have to turn on and off the constraint so that the keys can take over. But the keys and the constraint can't be happening at the same time. So the other reason why we have controls like this is that we're able to freeze the transforms on the controls when we move them. So that gives us nice clean values to work from in our default pose. And then it makes it really easy to just type in zeros and ones to get back to our bind pose. So you can see if I click on one of these joints, there are values on Translate X, and obviously for a more complicated character, you're going to see just weird values in Translate X, Y, and Z that you're not going to easily be able to remember. So in this way, we can move the control, we can freeze its transforms, and then we can set up the constraint so that we have a nice default pose that is set to 0 and 1. So that is what we're really looking for with a control. So those are some of your basic constraints. Now, we do also have connections that we can make, an actual direct connection. So usually you would use a connection editor, which is under Windows, General Editors, and there it is, connection editor. And it looks like this. And it's going to have two columns. It's going to have your output connection and your input connection. And these can flip with this button from and to. So it gives you basically every attribute that exists for this object. And then you have to select the other object that you're controlling, and you would reload it in the other column. And then it gives you all of these options that you can use. So in this case, what I did is I used the translate of X. So if I come down and I find my translate and open that up, you'll find there's my X. And I connected to translate Y. So if I come over to translate, you can see there's this connection that's happening. It's already been set up. And what that does is it's going to take the value that I have set on my control, and it's going to directly connect it to the value of this. And you can see it makes that channel yellow. So yellow means there's some sort of direct connection happening. So we can do it through this, or we can do it through our node editor. And the node editor also under here, under Windows, and there's the node editor. The node editor looks like this. You can select an object like that joint, and we can actually click the little sparkly button that will clean off our node editor window. And then if you click the double arrows, it's going to map the input and output connections. And we can actually see, so here's the joint that we have selected. These are all the connections that are happening to it in a visual manner. So we have our connection control. That's what I've named it here. And I can open this up by clicking these icons, and it will expand it. And you can see this is my input side, this is my output side. So I have translate X, and you can see it's coming in. If you highlight on it, it'll tell you what's happening. It's going connection dot translate X is going into joint 6 dot translate Y. And if I expand this out, you can see there's that. So yeah, you can make other connections of translate Z going into translate Z, and it just makes that connection there. It's the same thing as coming here and doing translate Z. That unconnects it, that reconnects it, and that is totally fine. So it's just on the right side, you will find your outputs, and on the right side, you will find your inputs. So you'll usually see things strung out from left to right, as that's the way that things flow. So this makes a direct connection, and the value of this is directly what this value will be. So if you're controlling something like a joint, you'll notice I did not actually let me undo these. There we go. So with this, I have the translate Z set to -5 here. So when I connect this, this value of translate Z is 0. So when I make that connection, it moves this forward to where the 0 location is, which is right at world 0. So you have to be careful about the connections and what you're connecting to whenever you're doing a direct connection through the connection editor or through the node editor. Okay, so those things will change stuff, and you just have to be aware that this is a direct value. Whereas on constraints, you can have different values, and that's what that maintain offset does. So there is a value on here, but there's no value on our control. So with this connection set up, it's just a 1-to-1 ratio. So if I move it left or right, it's moving the object up and down. So you can see how that kind of helps you manipulate different objects to function a little differently than you might anticipate, but will make it easier for an animator to work with. So the last thing that I want to talk about is a set-driven key. Now, a set-driven key makes a connection similar to our connection editor, but in this case, it does it through our graph editor, like you're keying normal animation. So in this case, I have this chain. And this is a good use for a set-driven key, because there are times where you want to go in and you want, we have this chain. If I go into wireframe, you can see it's not a complete chain. It doesn't go on forever, but maybe we want to make it look like it is coming out of these two tubes and it's just this ever-running chain. So we can do that with the set-driven key. With the set-driven key, you can access that by clicking on the object, selecting one of the attributes you want connected. So in this case, you'll see it has a blue connection there for a set-driven key. And then there's an option in your channel box under Edit called Set-Driven Key. And that will pull this up. Now I've already set this all up, but it will show up, it will automatically populate down in your driven what it is, along with all the attributes that can be driven. And then you have to select your other object and load the driver. And then you can say, hey, I want this driver, and I added an extra attribute for the chain, and I want it to drive this. And so I can go in, you'll notice that there's this key option that's available once I highlight it. And you would set a key in the normal state, and then instead of using your time slider to determine the change, you're using this driven attribute. And then you would say, hey, now I'm going to go to frame 10 here, and then I'm going to come back to my driven object, and I can punch in or move that attribute, and then I would set another keyframe on that. And then using your graph editor, this is what the graph looks like, and go in, I just set everything to linear, and then I said I want this to cycle, just a straight cycle before and after that. So you can see that's what my graph looks like infinitely. And what that does is gives you this infinite chain. So now it just looks like this chain is never ending. Because what it's doing is I'm moving it down basically a whole space, and then as soon as it gets to that, it immediately snaps back to the original position. But because it does it in one frame instantaneously, it gives the appearance that it is actually going forever and ever. But if I go to wireframe, you can kind of see what it's doing. And we're just hiding that. So those are a lot of common things that we will use in setting up our character. So we are going to be creating controls and constraining the joints to the controls so that we can easily access and use these controls to move and animate our character more easily and create a lot of functionality. So that is just a little bit of learning for what constraints are and different connection types that we will be using. So in our next lesson, we will jump into starting to create controls and start getting our character all set up.